Hello students, today I am here in front of you with the mathematics of class 10th NCERT English medium, and we are starting with chapter 1 real numbers. So what are the real numbers? Real numbers are the numbers, rational numbers and irrational numbers taken together. So very simple definition to learn. Rational numbers plus irrational numbers. Rational numbers plus irrational numbers, when they are taken together, they form what? Real numbers. Now the first theorem of this chapter is theorem number 1, theorem 1.1, and the name of this theorem is Euclid's division lemma. Euclid's division lemma. Now what is this lemma? We need to understand this. Let us suppose you are given two positive integers for any two positive integers a and b, we can find unique integers q and r, unique integers q and r such that a is equal to bq plus r, and there is some condition with that is 0 less than equal to r less than b. Now this definition is very difficult for the students to understand this. This is very difficult for the student to understand this definition. Now how this definition one can understand? Now for any two positive integers a and b, we can find unique integers q and r such that a is equal to bq plus r, comma, this is the condition 0 less than equal to r less than b. So generally students cram this definition and they don't understand the meaning of this definition. So for understanding this definition, I will take an example of two integers. Let us take example here. Let we have two positive integers 3 and 7. Now if I divide this 7 by 3, so 3 2 is 6, 1. Here you see positive integers 3 and 7. So a is 3 and b is 7. For any two positive integers a and b, b can find unique integers q and r. So you see that we have 3 and 7 and we have two more numbers. One is here 2 and other is here 1. So two integers we have found and these integers are unique. Now you can see by division algorithm that 7 can be written like this: 3 into 2 plus 1. Now you see it is same. A is equal to BQ plus r, right? A is equal to BQ plus R. Here A is 3, B is 7. And what is R? R, you can see R is here 1, remainder. So for any two positive integers, we can find two more integers by dividing it. And you see, we have two positive integers, A is equal to 3, B is equal to 7, and you divide it and you get two more integers. This integer is Q and this is a remainder R. So for any given two integers 3 and 7, we have got two more integers, and these are unique. They are unique. They cannot be any number. They are fixed for these two given integers 3 and 7. They will be 2 and 1 only. So A is equal to BQ plus R. R is here 1. So this is how we understand. Now in simple words, when we divide two integers, we will get two more integers, and those integers are, one is quotient and one is remainder. And you know that this 7, we call it dividend. Dividend is equal to divisor into quotient plus remainder. So this is how we understand this Euclid's division lemma. And this R, this number R is lying between 0. It may be equal to 0 or may be less than B, right? So remainder can be, you can see in some other example, if you divide 6 by 2, so 2 3s are 6. Okay, here remainder is 0. Again in this example, A is equal to 6, B is equal to 2, Q is equal to, B is equal to 3 here, Q is equal to 3, and R is equal to 0, right? Now if you apply here again that lemma, it will be, this condition will be satisfied, that A is this one, 6. So 6 is equal to 2 into 3 plus 0, means A is equal to BQ plus R. Here R is 0, right? So this is how we understand this Euclid's division lemma. So I hope this will be clear to you. Now in this, the next topic is, what is an algorithm? Very basic definition. You must understand this. What is an algorithm? Algorithm. Algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. Means some steps are there. They are connected steps. First step, second step, third step, fourth step. And they give us a procedure for solving a problem. An algorithm is a series of well-defined steps, is a series of well-defined steps which gives a procedure which gives a procedure for solving a type of problem. For solving a type of problem. So this word we will use in questions. That's why I'm making it clear. An algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. Means there is a procedure in mathematics. In this first chapter, there is a procedure to solve a problem, and that procedure has some well-defined steps, and this is called algorithm. Right? Now here one more definition. What is lemma? Lemma is a proven statement which is used for proving another statement. A lemma is a proven statement used to prove another statement, means you have one statement which you have proved already, and we will take its help to prove some other statement. Okay, so this is the definition of the lemma. This is just basic definition. These are not going to come in your examination, but you must know these terms, that what is lemma and what is all that. Okay, now we have studied that what is Euclid's division lemma. Now this Euclid's division lemma can be used to find the HCF of two numbers, right? So next is use of Euclid's division lemma or division algorithm, right? Use of Euclid's division lemma to find HCF of two integers, two numbers, you can say positive numbers, obviously positive integers. So there are some steps in this, as we have already stated that algorithm has got an series of steps. So this is how an algorithm is there to find the HCF of two numbers. Now in this, let us suppose we have two numbers C and D. Let we have two positive integers C and D, okay, with C greater than D. Then we have following steps to find the HCF of these two numbers. Then we have following steps to find HCF of C, D. Okay. Now first step is step number 1. What we do, we apply Euclid's division lemma to C and D. We apply Euclid's division lemma. We apply Euclid's division lemma to C and D, to C and D, to find whole numbers Q and R, to find whole numbers Q and R such that now here C is greater, so C is equal to two numbers these and these, C is equal to DQ plus R, comma 0 less than equal to R less than D, right? This is same as we are dividing two numbers. Here we will divide C and D and we will get some quotient Q, we will get some remainder R, and R will satisfy this condition. As I have already given you an example, for example, you divide 11 by 3, so 3 3s are 9, 2, okay. So here what is C? C is 11. What is D? D is 3. And what you found Q? Q is 3. And what you found R? Remainder R is equal to 2. So we can write this number C, which is 11. I have missed here 11. 11 can be written like this. DQ means 3 into 3 plus 2. And you see it is like this, same as it is here. C is equal to DQ plus R. And how this condition is satisfied? You see R is equal to 2. So it can be, R can lie between, can be equal to 0 or it can be less than D. Now what is D here? D is 3. Now you see this 2 number which is R, I can write 2 less than D. D is 3 and less than equal to 0. So here this condition is satisfied. This was the condition. So in first step we applied this and we do this one. Now after doing this, what is the step number 2? In step 2, if in the step 1, if R is 0, then this divisor, what is the divisor here? Divisor is D. Then D is HCF of this number, right? Then D is HCF of these two numbers C and D if remainder is 0, right? And if remainder is not 0, then we will continue this process, right? If remainder is not 0, if remainder is not equal to 0, then what we do? Then we apply Euclid's division lemma. Then we apply Euclid's division lemma to what and what number? We apply Euclid's division lemma to this number, means we have found Q and R, right? We apply Euclid's division lemma to this D and R. D and R. That is here D is what? 3 and R is 2. Right? D and R. Now let us continue in next page. Now what are D and R here in the example? You see here in the example D and R are here. D is, you see here, D is 3 and R is 2. We will again apply here 3, 2, 2 1s are 2, 1. So we have applied division lemma to D and R. So what we get here, again we will get what in step 3. If again R is not equal to 0, then continue applying the Euclid's division lemma. Euclid's division lemma till you get R is equal to 0. Again here R is not equal to 0. Now again we will apply Euclid's division lemma to this and this. Here again D is equal to 2 and R is equal to 1. So again we will apply it here. I will write 2 here, bigger number here, and 1. So 2. So who has divided in the end? 1. So here last divisor is the HCF. So HCF of 11 and 3 is equal to 1. So this was the steps with example. I hope you will understand this and will be able to solve the problems. Now there are some remarks, or there are some points to be noted. What are the points to be noted? Points to be noted. Our first point is Euclid's division lemma and algorithm are very closely interlinked. Euclid's division lemma and algorithm are very closely interlinked. Right? Second point is they are very closely interlinked. They are taken for one another. Right? We can also write that people often call them, somebody call them division lemma. Okay, algorithm, they are same. Euclid's division lemma and Euclid's division algorithm, they are same. People take them as same. Okay, they are very closely interlinked and are sometimes taken as same. इनको एक ही मान लिया जाता है. Now our second point is that Euclid's division lemma or algorithm is stated for positive integers. It can also be extended for negative integers also, except 0. Euclid's division algorithm is stated for positive integers, but it can also be extended to negative integers except 0. Means division by 0 is not possible. That is, b cannot be equal to 0. Or divisor cannot be equal to 0. Now here you must understand the difference between Euclid's division lemma. Lemma is a statement, okay, used to prove another statement. Algorithm is a series of steps. Here we have steps for finding the HCF of two numbers. So it is use of Euclid's division lemma to find HCF. Now when using this lemma, we are having some steps. So lemma's steps, when they are written, these steps becomes an algorithm. Right? This is very important that you must understand the difference between lemma and algorithm. Lemma is used here to make some steps to find the HCF of two numbers. So first step was that you just divide the bigger number by the smaller number and you get this condition. You can find two more numbers, Q and R, and that R can be less than D here. R can be less than D. D is 3 here. Again, if R is 0, then D is HCF. Last, if the divisor which makes the remainder 0, that is the HCF. Here it is not able to make the remainder 0. So again we will apply Euclid's division algorithm or lemma to 3 and 2. Right? So here in the next page we have applied it to 3 and 2. Again we see division is not 0. So we will continue applying Euclid's division lemma to get R equal to 0. When we get R equals to 0, the last divisor, that is here 1, is the HCF. Right? So if R is not equal to 0, then continue apply Euclid division lemma till you get R. Now to which numbers we have to apply Euclid's this lemma? To the remainder and the divisor. To divisor and remainder. And when we get remainder 0, that last divisor is the HCF of these two numbers. So these are just steps, and this series of steps is known as algorithm. Euclid's division lemma and algorithm are very closely interlinked to each other. They are sometimes taken as same, right? And Euclid's division algorithm in this chapter we have stated for only positive integers. However, it can also be extended to the negative integers. So this was just basic knowledge. We will start with the questions of exercise 1 in the next video. I hope you will understand these basic things. Thank you.